John, are you there?
Yes, yes, I am here.
Oh, Saremar also.
Yes,
Good
can you
afternoon, sir.
hear me?
Acha, yes, I can hear you, but your this one is slightly up. You have to put down slightly the what do you call?
6 o'clock I'll start.
Yes, 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 yes. No, not 6 o'clock. Introduction, you will give welcome speech, na sir? Hello? Sir, your network is bad. Sir, can you hear me? Saremar? Sir YS? Sir Yuvraj? Sir. Saremar? Your voice cannot be heard, Saremar. Unmute once again. No, cannot be heard. It is muted. It is muted.
It is.
Yes. थोड़ा
Yes, sir.
कैमरा तो थोड़ा डाउन करो.
Yes, yes.
हाँ, होगा.
Okay.
हाँ, okay.
Can you hear me now?
Yes, I can hear you clearly. What
Okay.
about me? Can you hear
Yeah,
it?
yeah, I can hear you properly. Yeah.
Okay, fine. Thank you. Okay. Let's see how many are joining.
Yes, sir.
Some people joined, but they have left now.
Yeah. Some join it since.
No, now left. Only
Oh,
two of us.
okay. I think by the time 5:55 they will come, I think, again.
Gaurav.
Some join, they left again, no? Yes, sir.
No, Sir GB was calling.
It is unmuted only.
Yes, now it is okay.
Okay. Because of
Yeah.
maybe.
John, please allow Gaurav also to come in.
Gaurav.
Gaurav is trying, it seems. Father,
Yeah.
can you hear? Good afternoon. Good evening, Father. Good evening, Father.
It's okay.
So good evening, Arindam.
Yeah.
Good evening, Rajbongsi.
Father,
Can
good
you
evening,
hear?
Father. Yeah,
Can
I
you
can
hear?
hear. I can hear you, Father.
Okay.
Okay.
Now I put on my screen. Can you see me?
Yes,
Yes,
Father.
Father.
Yes, we can see
Yes.
you,
Okay.
Father.
Yeah.
Only thing, Father, your voice is slightly low. Volume.
Now,
Yeah, better.
because I was keeping this one far.
Slowly.
Okay.
No, slowly joining, sir.
Yes. Westerly, Jordana.
Jordana, yes.
Sir Yuvraj, can you hear?
Yes, sir, I can hear.
Yes, sir. If this one is not good, internet is not good, you just put off the what do you call? Whoever
Video.
internet is not good, put off the video and only put on the audio.
Audio, yes. Mm.
So another thing is that, sir Yuvraj, that
Sir.
in YouTube, if by chance some questions are there, so we have to take those into account.
Okay,
They
sir.
might give some questions in YouTube also.
Okay, sir.
So we
Okay,
have
sir.
to note down. I'm ready with that. So you also please note down. I just request means when possible, because mainly question answer session will be done by you. Of course, I will be there also, because God knows about the network when it goes down. So anyway, this one, I have rang up
Yes, good evening, Father.
Father has muted.
Sir, can you hear me?
Yes, yes, yes.
Okay. Okay, sir.
Abhimanyu, can you hear us? Abhimanyu, Westerly, can you hear us?
Yes, sir, I can hear.
Okay,
It's
fine.
good.
Okay, thank you.
You're audible, sir.
Okay, Abhimanyu, I could hear. Yeah.
I think Sir Yuvraj has some problem. Okay, okay.
No, no.
Hello.
No, it's okay.
So good
I'm
evening,
just-
everyone.
Yes.
Another 6,
Good
7
evening,
minutes more,
Father.
no?
Yes, Father. Yes, Father.
Where is Saurabh? Where is Gaurav?
Gaurav is there, Father.
Yes.
Okay.
Yes, Father, I'm here, Father.
Where? I cannot see you.
Oh, Father, my network is not that I've been good, so I have to talk in audio only. Video will be a problem here.
Is my voice clear?
Yes, Father.
Okay, thank you.
Just to let everyone know, this is being live streamed right now in YouTube. I'm just checking there. So we are live. Someone please say something. Now everything is ekdam quiet.
No, it's okay. It's okay. I was just checking because still some one more has joined, and Father Vice Principal also sent me just now one more joined. So I am giving the YouTube link.
Sir Habul, Sir Madhu is here. Can you hear us, Sir Habul? Oh, this is Father Vice Principal.
Father Vice Principal has also joined.
Good evening, Father.
Father John Paul, where are you?
Yes.
Ah, he is in the office.
Gaurav is there, Father.
In this one, there are only 18 so far. 1-8.
Yes, Father. Only 18 are there.
Sir, some participants are asking for the link. Just now I got some message in my personal WhatsApp, sir.
You sent
You said
the YouTube link.
you
I have been repeatedly sending there. Please send the YouTube link only.
Okay, okay, sure.
I'm going to share the YouTube link in the chat. If anyone does not have the YouTube link, where is the chat? Things have changed so much because getting used to.
it's okay, yeah. Yes. All total has. Yes, yes. Sir Habul, can you hear us? Sir Madhu, can you hear us?
I can hear you.
Okay, sir. Thank you. Thank you so much. Welcome.
Thank you.
Father, he joined, no? Father Vice Principal. You send the link. YouTube link you send. Madam Uma has joined. Good evening, madam.
Good evening, madam.
Madam
think
Uma,
she's-
can you
she's
hear
not-
us?
Mr. Rajbongsi,
Yes, father.
is my audio clear?
Yes, father. Your audio is clear, father.
Okay.
Father, anyone else is joining from Salesians province or someone like that?
Yeah, there will be quite many. I think they will come in by and by.
Okay, Father.
Father Pius is supposed to join.
Okay.
Father Trenius, and there are quite many others to whom I have sent.
Okay, Father.
Madam Uma joined, no? Madam Uma. Yeah, you should better.
Brother Rashid is also joining. My audio is on, no? Mr.
Yes, Father.
Rajbongsi?
Yes,
Yeah.
father. Your audio is on, father. Yes, father. Father's audio is gone, I think. Hmm? Hello? Aji, can you hear me?
Yes, yes.
Okay. Sir Saros has joined. Good evening, sir.
Hello. Am I audible? Good evening.
Yes.
Hello.
Evening, sir.
Yes, yes.
Yes, good evening, sir.
Good evening, everybody.
Thank you,
Good
sir.
evening, good evening.
Most welcome, sir. And thank you for joining us.
Thank you very much.
Thank you for making yourself available to animate us today. Yes, sir.
Nice to see you.
Thank you very much. Thank you very much.
Uh, Sir Soraj, that was Father Principal of our college, Father Janurius Sangma. Can you hear me?
Good evening, sir.
Yes,
Yeah,
yes.
good evening. Good evening.
Good evening.
Yeah, good evening. So this is Father Janurius, our principal. So he was welcoming you with waving the hand.
It's my privilege, sir.
Thank you for joining us. We'll take a little bit, we'll just wait for 2-3 minutes to start off.
$29, and 80, 29 and 80, 109. That is in YouTube, no? Sir AG,
Yeah,
in YouTube, 80 has joined.
yes.
Yeah.
Sir John, can you hear me?
John.
Or
Yeah,
Sir, Sir Yuvraj also, please remember to give the feedback link. Sir Yuvraj, feedback link is there with you also, right?
Yes, sir.
Okay.
We had discussed earlier, we'll be giving it in the WhatsApp group, we'll be giving it in the Zoom as well as in the YouTube.
Yes,
in all
yes.
the-
Yes.
Hello, sir.
Let us wait for, let us start at 6:05, another 3 minutes, let's wait.
Okay, sure, sir.
Still some are joining, so. So, Sir Saroj, how is the weather in Silchar?
It is fine, a bit hot nowadays since the last 2 days. And
Okay.
overall, it's okay.
No
In
rain.
Silchar,
No rain.
most of the time, no, most of the time rainfall happens, but last 2 days there is no rainfall. But hopefully, you know that if this kind of this situation continues for 7 days, so in Silchar there is a probability to happen rain actually.
Yes.
My voice is clear. Whether
Yes,
I'm audible
yes.
clearly or yeah.
Yeah. Little unclear, but more or less clear only. Sometimes
Okay.
it's slightly unclear.
Actually, see that it happens in a Zoom meeting link actually. So had it been say
Google.
the Google Meet, so
Yeah.
sound could have been clear, I think.
Yes.
But quite audible enough, sir.
Oh, thank you very much, sir. Yeah. So I think in your college you have master degree also, right? Today some master degree students they will join also, I think.
No, we have only the UG, up to the UG
right.
level. Hmm.
Yes. And your faculty members, they are doing research. I think some of them are publishing papers and doing some kind of research work.
Yes, that is true.
Yeah. Then it may be benefited for them also for UG level because I got the feedback from Dr. Arindam Ghosh. So UG level and the faculty members would be there. So in line of that, actually, I made. So there would be the contents, fundamental contents, some technical contents, some content from the research point of view. So all kind of things are there.
Will you be using the presentation screen on the screen?
Yeah.
Okay.
Yeah. I'll be sharing.
Okay. That will be nice. We can begin soon. In the beginning, we will have few preliminaries, welcome speech, introduction, etc. And your animation proper will come little later.
Oh, yes.
How many there now? YouTube, how many there? YouTube. Hmm?
Yuvraj? Sir
Yes,
Yuvraj,
Father.
how is in the YouTube?
Father.
How is in the YouTube?
YouTube is it's going on, Father. It's there.
Okay,
It's quite clear.
okay.
Sir Yuvraj, can we start the proceedings?
Yes, sir. I think
I think we can
because
start. It's already 6:05.
Yeah.
Yeah.
So, just to start off the proceedings, I welcome everyone from my side, being the convener. Of course, the welcome speech will be given by our head of the department, Sir Mohidar Rajbangshi. Before that, a big thank you to Dr. Saroj for sparing time for us in order to be with us in this webinar. So I also welcome all the participants, our faculty members, everyone. May I now hand over to Sir Mohidar Rajbangshi to give
Yes,
the welcome speech.
Yes, sir. Good evening, everyone. I, Mohidar Rajbangshi, on the behalf of Physics Department, Don Bosco College, Thura, welcome you all for the today's webinar. The topic of the today's webinar is application of artificial intelligence and machine learning in smart decision making. I am extremely honored and delighted to welcome today's research person for the webinar, Dr. Saraj Kumar Biswas, Associate Professor in Computer Science and Engineering Department at NIT Silchar. His research interests are machine learning, image processing, artificial intelligence, deep learning, and data mining. Thank you, sir, for sparing your valuable time to deliver a lecture in the webinar. I am confident that all the participants will be greatly benefited. I am very grateful and thankful to our dynamic and energetic principal, Father Januarius S. Sangba, for his all source of cooperation and inspiration for allowing us to conduct the webinar. A sincere thank you, Father, and welcome to the webinar. Hearty welcome to all the respected professors, lecturers from different universities, colleges, various institutions, my esteemed colleagues from the Physics Department, Dr. Arindam Ghosh, Dr. Yuvraj Sharma, Gaurav Biswas. My dear students, ladies and gentlemen, a warm welcome to each and every one of you once again. Thank you everyone for your valuable participation in the webinar. Have a pleasant evening and enjoy learning. Thank you and Mithala.
Thank you very much. Should I start?
No, sir, I'll just wait for a few seconds, a few minutes.
Okay.
So
Thank you very
yeah.
much, sir.
Thank you, sir Mohidar Rajbangshi. May I now request our Father Principal to give the words of this one, welcome, as well as to just give a brief description of what we have, how he planned, because he was the main person behind this. So he has asked us. After this, sir, Sir Saroj, I will just introduce you once again in details. Then you please take up.
Okay. Thank you very much, sir. Thank you.
Father Principal, Father Janu, please. Can you unmute, Father? Father, please unmute.
Good evening, everyone. Can you hear me now?
Yes, Father,
Yes,
I can hear. Yeah.
So once again, I wish every one of you a very happy evening. Sorry. Respected Dr. Saroj Kumar Biswas, a distinguished resource person for today, members of the IQAC and the physics department, the organizing team of this webinar, my esteemed heads of departments, faculty colleagues, dear students, and all academicians, friends, and well-wishers joining us today. It is my great pleasure to welcome all of you to this webinar on application of artificial intelligence and machine learning in smart decision making, organized by the IQAC and the Department of Physics, Don Bosco College, Tura. A special word of welcome and gratitude to our distinguished resource person, Dr. Saroj Kumar Biswas, Associate Professor, Department of Computer Science and Engineering, NIT Silchar, for kindly accepting our invitation and being with us today. Artificial intelligence and machine learning are no longer futuristic. They are already transforming our lives. The global AI market is projected to reach nearly rupees 2 lakh crores by 2030. I got it from the website. From healthcare, where AI enables early diagnosis and advanced treatments, to business, where it helps forecast markets and detect fraud, to climate science, where it predicts disasters and promotes sustainability. AI is supporting human progress in powerful ways. At the same time, let us remember that the best intelligence is still the human person. What makes us unique is our ability to empathize, to value, and to choose wisely. Yet, there is nothing wrong in seeking AI and ML support. Every day, we make countless decisions, big and small, and these tools can help us analyze, understand, and act more effectively. We also wish that through today's session, we may all learn to take small, thoughtful decisions with confidence, for they often shape the bigger ones. This webinar is therefore an opportunity not only to understand the applications of AI and ML, but also to reflect on how human and artificial intelligence can work together for the greater good. On behalf of Don Bosco College Tura, I warmly welcome you all once again and thank Dr. Saroj Kumar Biswas for his valuable presence. Let us look forward to an engaging and enriching session. Thank you all and have a wonderful evening.
Thank you. Thank you very much, sir.
Thank you, Father. Thank you, Father, for those words. Let me now introduce Dr. Saroj Biswas. Dr. Saroj Kumar Biswas is currently working as an associate professor in Computer Science and Engineering Department at National Institute of Technology, Silchar. He was the head of the department from August 2021 to September 2023. His research interest includes machine learning, image processing, artificial intelligence, deep learning, and data mining. 19 MTech students have completed their dissertation under him, and 3 students are currently carrying out their MTech dissertation. Presently, he is guiding 10 research scholars. Also, 12 research scholars have completed their PhD under him. He has completed one DEITY sponsored research and development project and one NPIU World Bank sponsored research and development project. He has 86 journal publications, including 53 unpaid SCI or SCIE in reputed publishing houses like IEEE, Elsevier, SCM, IET, Springer, Taylor and Francis, etc., and 99 conference publications. He has published a total of 5 patents, including national and international. He has delivered 109 expert lectures or sessions, invited talks, and keynote speeches outside his institution in different seminars, workshops, FDPs, and conferences. He has more than 3,355 Google Scholar citations. Let's welcome him to present a talk on the topic Applications of Artificial Intelligence and Machine Learning in Smart Decision Making. Please, sir, you can take over now. Thank you.
Thank you very much, everybody, especially the organizer and the convener for inviting me. So now I'm going to present my presentation. And before that, just to ensure me my presentation is visible and it is also moving. Tell me it's moving or not. Please let me inform.
Yes, it is
It's
visible
moving?
as well as moving. Yes.
Okay. Okay, thank you very much. So the title of this, let me one thing, write my data. Have to be careful about the data actually. So let me stop this. Yeah. Okay. Thank you, everybody. The title
is it possible
of the
to make it
presentation-
full screen?
Yeah. I have done full screen. Is
Okay,
it visible
okay,
or
fine.
not full screen?
Okay.
Visible?
Yes, it is visible.
The title of the session is Applications of Artificial Intelligence and Machine Learning in Smart Decision Making. So in this session, initially, we'll try to define what is artificial intelligence. Examples or real-life applications where we use. If you want to develop something, then what kind of technologies and what kind of, say, theoretical foundation is required, that part we are going to discuss about. Thereafter, we'll define what is machine learning theoretically, and thereafter say a bit mathematically, what are the application of machine learning, and finally, if you want to design AI model, then how it can be designed. And also we have a lot of application of machine learning we're going to see one by one. In the first slide, I try to give the definition of artificial intelligence. So there is no unique definition of artificial intelligence. However, there is some kind of line so that if this boundary line crosses or if this boundary line happens, then we can say there is artificial intelligence. So according to the boundary line, we can say it is the study that how to make computers do to human being. This is one definition from Knight, one of the popular books of technology that enable computers or machines to do like human being. So artificial intelligence can be defined as a study or a set of technologies. The main objective of artificial intelligence is to make computers do the things like human beings. Computer means it can be any computing machine. It should be noted here. And nowadays, actually, we can see the application of artificial intelligence every sphere of our life and every sphere of the country as well as in the world. But there are some prominent applications. So those prominent applications are presented here. At the same time, if we want to design those kind of application, then what kind of mathematical foundations or the theoretical foundation is required, we're going to see in these slides and for subsequent slides. Number one, applications, maps and navigations. And this is used for traveling, right? So many times we use Google Maps or the Apple Maps in searching some places or so travel some unknown places, right? It's a kind of applications. If you are doing this kind of application, then what kind of mathematical foundations or the theoretical foundations are required? So the subjects which are responsible to make such kind of systems are machine learning, deep learning, data science, and then image processing must be known. With that, we must have some kind of domain expert, domain knowledge, especially for the domain for which we're trying to develop something. Similarly, we have another applications of AI, that is facial detection and recognition. So it is used for unlocking our phones and many applications. And we use these kind of applications in our day-to-day life. Now, if you want to design this kind of applications, the theoretical foundation which is required for that, and these are, means especially the subjects which are responsible to design this kind of applications, there's machine learning, deep learning, data science, and image processing. Thereafter, here we have text editors and autocorrect. So whenever we want to write something in MS Word, so if you write something, if the spelling is not right, then it is indicated that your spelling is not right. Even inside Gmail, if you want to write one email, right? So after writing a part of the sentence, what can be the next part or what can be the next word? It comes automatically. All these due to the advent of machine learning, right? So if you want to design such kind of applications, we must knowledge of machine learning, deep learning, data science, and natural language processing. Similarly, another application, search and recommendation. Item, we watch a movie or shopping. So we have seen that during shopping online. So we are shopping something. At the same time, the recommendation automatically sends us some items. How that is actually? Whenever somebody is interested, the person is also interested in which are related. And those related, that is by recommendation system. Now, if you want to design recommendation system, the subjects which are required for that, there's a machine learning, deep learning, data science, and many more can be. But these are very fundamental subjects. Thereafter, one prominent applications of artificial intelligence that is called chatbot. So it is used for interacting with customer for customer services. So whenever you go for some help from some organizations or some industry, if you want to buy something, right? So if you open up the organization's front page or like that, initially, if you enter to the website, you can see on the right-hand side, there is a pop-up menu. And it says that, how may I help you, like that. So it seems like that somebody is interacting from the opposite side, but that's not a human resource. Rather, it is an intelligent software. It is an artificially intelligent software, you can say the program, which interacts with us. So if we ask the questions, accordingly, it gives the answer. Now the question, how we can design those kind of things. So now to design those kind of things, the theoretical foundation which is required, those are the matter of the subject of, say, machine learning, deep learning, data science, and natural language processing, right? So this chatbot, you can see nowadays everywhere it is used. And the advantage of the chatbot is that it works every time, 24/7. Right? It's not like say human resource kind of thing, say from 9 to 5. So with the advent of this artificial intelligence, now anytime, anywhere, this kind of assistance we can get. And then here the social media. So the support of AI is used in social media to monitor contents, suggest connections, and serve advertisement to target users. Whenever we use a social media like Facebook, it can be linked list, can be WhatsApp, you can see those kind of things, right? Even Twitter. But behind that, if you want to design such kind of system, actually, the subject which are required, this remains same actually. Machine learning, deep learning, data science, natural language processing. Therefore, nowadays, actually, whenever we talk about the advanced technologies, the subject of the matter which comes, these are machine learning, deep learning, data science, natural language processing, image processing, and many more. So this is the essence and need of actually machine learning in AI system. Then also we have a medical diagnosis and treatment. So many times we want to design expert system. Even if the domain expert is not there, by this intelligent software, we can diagnose. Like for an example, say whether some tumor is cancerous or not. Just if we take the image of the tumor, then it can analyze and it can predict that whether this tumor is malignant tumor or benign tumor. This is one of the application of medical diagnosis. Similarly, whether somebody is suffering from sleep disorder or not. Okay, so by the instrument, we can take the EEG signal, EMG signal, ECG signal. It can be analyzed, and after that, it can be said that whether the person is suffering from sleep disorder or not. This analysis of the data, this analysis of the signals, all are done based on the data science and machine learning algorithms. So even if domain expert is not there, but if we have a data sets, if we have a trained machine learning system or the AI system, then it can predict or it can diagnose some medical complications. So in that way, actually, this is AI and machine learning can be used. And then after here, we have a drug discovery and vaccine research. Just this line is sufficient for that. The use of artificial intelligence in healthcare and medicine accelerates drug discovery and vaccine development, actually, which happens during the corona. So due to that, actually, we got the vaccines very rapidly, means with shorter duration of time. Then we're coming here. Whenever we talk about the AI, then we say that is the machine learning. And whenever we say machine learning, that is the AI. So what is the relationship between them, AI and machine learning? Just I'm trying to establish by this slide. Now say that some expert who is in machine learning or someone who is a domain expert, he wants to design one medical expert system using AI actually, right? So now say this medical expert system is heart disease prediction. He wants to design. So he wants to design one heart disease predictions expert system. Then how it can be designed? For that, it has two ways. One way is called by domain expert, and another way is by machine learning, right? So by domain expert means how we can do this one. So if we have a very expert cardiologist and very expert doctors who has a vast experience on say heart disease, and he knows many things about heart disease, and he could understand that out of all of the parameters, especially for the heart disease, say blood pressure, blood sugar, and cholesterol, these are the responsible only, right? By these three parameters, we can analyze. This is an assumption only, try to understand, right? And that expert cardiologist has made some rules. And these rules are what? If BP greater than 200 and BS greater than equals to 190 and cholesterol greater than 270, then the person is suffering from heart disease. Then it is written as S. It's a kind of rule, right? Rule can be presented in a form so that some kind of reasoning can be done there. It's a kind of condition. This condition can be implemented by programming. And else if another condition is what? The syntax can be anything, but he has three rules. The second rule is what? If BP greater than 150 and BS greater than equals to 170 and cholesterol greater than 300, again, the person is suffering from heart disease. If these two conditions are not satisfied, then the person is not suffering from heart disease. Clear? So in this case, you see that these rules are made by a domain expert, right? Now, these rules can be implemented by forward reasoning or the backward reasoning. Then one expert system can be built, and that is the AI system. But here the AI system is built by domain expert, right? So one thing can be noted here, whenever we make some kind of expert system, there would be more than 1,000 and 1,000, more than 1,000 and more than that actually, rules would be there because it should cover all the cases. This is an assumption to have better understanding. I have presented here only two rules here. But in reality, we can have 1,000 and thousands rules to implement or to make one expert system. So these rules are codified, and now these rules are available as an intelligent software. So now onwards, even if this expert cardiologist is not there, that just if he can find out the values of blood pressure, blood sugar, and the cholesterol, then this can be given and the expert system can find that or can determine whether the person is suffering from heart disease or not. So in this case, we have designed the AI system, but there is no use of machine learning. Why? Because already we have a domain expert. Fine. But many times domain expert may fail because the data says something and the domain expert may not have that kind of knowledge because the data is having many things. Data is magic actually. Within the data, we can have different kind of patterns. Even if domain expert is there, sometimes we rely on the data. It can have two situations. Say we want to rely on the data, or second situation can be say we want to design something, but the domain expert is not there. Then what we will do? So in this case, say that if domain expert is not there, then can we design the heart disease prediction expert system? The answer is yes. Then how that is actually? Then we have to assume that whenever some person comes to diagnose heart disease, his record is recorded. Means each of the entry, the record is recorded in a database, right? So this is the first person. That a BP is this, heart is 190, cholesterol 300. Yes, he was suffering. It's a historical data. Similarly, in the clinic, the second sample says that if BP 125, BS 200, cholesterol level 290, then yes, the person was suffering from heart disease. Like this, we can have 1,000 and 1,000 records in a clinic or the hospital about the heart disease prediction or about heart disease of the patients. We can have. So if we have this kind of data, then what we can do without consulting the domain expert, because domain expert is not there, now we can analyze this data. And then we make such kind of rules, right? So how we can analyze this data? Using some machine learning algorithms. In machine learning, there are different kind of algorithms, right? So those algorithms can analyze this data and they can form this kind of rules or some other kind of knowledge representation. So if we want to make this kind of rule, again, to make this kind of rule, we have the machine learning algorithms like say decision tree. So this decision tree can analyze these data sets and then it can make or it can generate number of rules. Say that we have this data set and decision tree is applied here. But for your information, I'm telling whenever we want to make one machine learning model from the data, the number of samples should be very high. It should be more than 10,000, more than million actually, because it is about learning from the historical data. So if the amount of the historical data is huge, then the learning generally, you can say the capability and the reliability would be something better, right? For the sake of simplicity, just we have a very small database here. Now, say G3 can be applied here and this kind of rules can be formed. You see that the rule says what? BP greater than 200 and BS greater than equals to 180 and cholesterol greater than 290, then we can say yes. Again, we have this rule. Again, we have this rule. Now, these kind of rules can be generated. These are only assumptions, try to understand, right? So this kind of rule can be generated, even if we don't have a domain expert. Just if we have a data set, from this data set, this kind of knowledge can be extracted. So once this knowledge is extracted, now it can be codified and once expert system can be made. So in this case, again, we made AI system for heart disease prediction, but in this case, this AI is using machine learning, right? So keep in mind that AI can be designed without machine learning, and AI can be designed with machine learning. It means that machine learning is a subset of AI. So AI doesn't mean always machine learning. But if we say machine learning means we are trying to make one AI system, actually. So this is the relationship between AI and machine learning. We have seen the definition of AI. Now we try to understand what exactly this machine learning does and how it learns from the data. So with an example, we're trying to understand here. Okay. So this is one way of the learning, right? So in machine learning, there are different ways. This is one way. This is called gradient-based learning. So we're looking at how in gradient-based learning, machine learning learns. So initially, we're trying to say again one definition of the machine learning. One thing can be pointed out here that again, we don't have any universally accepted definition for the machine learning, but we tried. Just I have taken this definition from Alpedin. This is one of the famous book of machine learning. So in this book, it says that machine learning is programming computers to optimize a performance criteria using example data or past data. Means we must know the programming and the programming has to be done. By this programming, what do? We optimize a performance criteria using example data. So we optimize a performance criteria of whom? So whenever we do something machine learning job, means we are doing some kind of machine learning task. So under machine learning tasks can be classification, can be regression, can be clustering, can be association rule mining, can be pattern recognition, so many things can be. Now we say the one of the tasks we're doing here, and that is classification. If the task is the classification, then for the classification, the performance criteria can be, one of the performance criteria can be accuracy. It means if the task is a classification, in that case, machine learning will make one program, and this program will optimize the accuracy from the historical data. Means for classification problem, our objective is to optimize the accuracy from historical data automatically. How that is from the historical data we can increase automatically. For that, we have an example here, right? So this is for the sake of simplicity, I made a very simple data set here, right? So in this database, you see that each of the sample is being represented by two parameters. One parameter is BP, means blood pressure, and second one is the class level, whether the person is suffering from heart disease or not. Okay, so for the first sample, if the value is 200, then the class level is S. For the second sample, if the BP is 250, then the class level is S. Like similarly, for the third sample, if the value is 130, then this is no, this kind of thing. And we assume that total we have 16 samples, but I have presented here only 7 due to paucity of space only here, right? Now, how we can solve this problem? For the sake of simplicity, again, we can consider that it's a problem. It's a binary class classification problem, okay? But this problem is also linearly solvable problem, means it's a linear problem. Because solving linear problem is a bit easier than the non-linear problem. So it's a linear problem now, okay? So total number of positive samples, we have 9, and total number of negative samples, we have 7 here. Now, and it's a binary, it's a classification problem. So if we want to represent this mathematically, then how it can be represented? It can be represented by a discriminant function. And in this case, the discriminant function has to be written in this way. Why this is actually? Say that how many independent parameter is there? Only one independent parameter, that is x1. So we have x1 here. And with x1, we have a coefficient that is being represented by w1. With w1, we have a bias here. This bias is given to get rid from overfitting problem. And with that, we're trying to map with y actually. So it's a discriminant function. As the problem is linearly solvable, therefore this discriminant function is called linear discriminant function. Mathematically, it has to be represented. Because the problem is solved mathematically, thereafter this mathematical part is codified by programs. Now, to have a better clarity in the problem, let's say we want to represent this problem graphically so that we can understand what is machine learning in a better way, right? So we want to present it graphically. Now, say that is y. Y means how? What? 1. Y means what? 1. No means what? 0. We can consider like that. In some algorithms, it is being represented like that. Y means 1, Y means 1. No means 0, 0, 0. This kind of thing. If this is, then the 16 sample can be represented in this way. One of the representation can be like this. How that is actually seen? This is X value, and this is Y value. And now say this Y value here, all samples are here, negative samples are here. So now we can consider this is 0, value Y equals to 0. Here at this line, Y equals to 0. Especially it is here, but in my diagram I made like this. So now we can consider Y equals to 0 here and Y equals to 1 here. Okay, take the first sample. How much is the value of x1? 200. We can consider 200 is here. And what is the value of y? That is 1. So 1 can be here. Okay, so this is the y dot. And the class is what? Positive class. Similarly, we can take the second sample. How much is the value of x1? That is 250. So 250 can be here. How much is the value of this class level? That is 1. So 1 is here. So second positive sample is here. Like that, all of the positive samples can be here based on the values of x. Similarly, all of the negative samples will be here based on the values of x. For the sake of simplicity, we have presented like this, right? So all of the white dots, these are the representative of positive class, and all of the blue dots, these are the representative of negative class. Okay, now we have to solve this problem. It's a binary class classification problem. So see here, if we can make a graph like this is a graph, right? This is a graph. If we can make this graph, then then the problem can be sorted out. How that is actually? One side of the graph can be considered as positive, and another side of the graph can be considered as negative, right? So now to have a better visualizations, we can think like this, right? So in reality, in most of the algorithms, whenever we have y means it can have some values, right? It can be 0.7, 0.6, 0.8, right? So for an example, as it's a binary class classification problem, therefore we have a threshold value 0.5. So whenever the values is more than 0.5, then we can say this is positive. If the value is less than 0.5, then we can say this is negative. Or less than or equals to. We can consider like that. So for some positive, we can have a 0.6, 0.65 like that. So in line of that, actually, we presented all of the positive patterns, and the presentation is like this. These are the white dots. And similarly, these are the negative patterns. Okay, so if the space is like this, in this case, if we can have a graph like this, so then the problem is solved. We're looking at as this is a linearly solvable problem. Therefore, this problem can be sorted out by a straight line. The graph is a straight line. So now if you see the discriminant function also says that the graph should be a straight line. But think that when the graph or the line comes here, only then the problem is solved. Because then only we can consider one side of the line is positive, another side of the line is negative. But if the line is here and here, then the problem is not solved, as the problem is linearly solvable. Therefore, we know that the accuracy, what we can achieve here, that is 100%. Therefore, the line should be located here. But then now the question comes that how the line can be located here. Once the line is located here, then the problem is solved. For that, we have to understand here. So this is the mathematical expression, or that you can say discriminant functions for this graph. So you see that whenever the value of C and W1s are changed, say the location of the line, see y equals to, when the value of C is how much? 1.5. And the value of W1 becomes how much? 0.9. Then the location of the line is here. When the value of C becomes 0.8 and W1 becomes 1.5, then the location of the line is here. So from here, it is clear that the location of the line is completely governed by two parameters in the equations. And these are what? C and W1. Okay. Now, if we can control, or if we can find the value of C and W1 in such a way so that the location of the line is here, then the problem is solved. Okay. But keep in mind, in any machine learning algorithm, whenever we have some model parameters, these model parameters value, we don't know exactly. Our objective is to find the values of the model parameter to solve the problem. That is called machine learning. Machine learning means algorithm is already available, right? In the algorithm, we can have a number of parameters. For what exact values of this parameter we can optimize the performance criteria. Try to understand. We had one statement here to optimize a performance criteria. How we can optimize? Simply we can optimize if we can optimize the values of the model parameters. So in this problem, it's a very simple problem. In this problem, the two model parameters are there, and these are what? C and W1. Our objective is to find exactly the value of C and W1 based on this historical data so that the problem can be solved. Machine learning means learning exact values of the model parameters so that the problem can be solved. Now the question comes, how we can learn? That's a big question. So initially, we don't know anything. So for any kind of machine learning algorithm, initially the values of the model parameters should be random. So we can keep here random values for C and W1. As the values of the parameters are random, therefore the location of the line is also random in the coordinate geometry or two-dimensional space. So for the time being, we can consider with the random values of C and W1, the location of the line is here. Then this is the random location. So when the location of the line is here, and we have assumed that one side of the line would be considered as positive and another side would be considered as negative, right? So this side is positive of this line. So how many are predicted as positive? Only 3 patterns are predicted as positive, okay? And out of 13 patterns, 7 are the negative patterns. So how many are exactly predicted as negative? Only 7. So exact predictions of 7 patterns of negative and exact predictions of 3 patterns of positive. So total 10 patterns are predicted exactly, accurately. So these 3 are positive. So these are positive. But this side of the line, these are all negative. This one is negative, 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 negative. All are negative. This is the predicted value. So out of these 13 negative patterns, how many are exactly negative? These 7 are exactly negative, and these 3 are exactly positive. So out of 16 patterns, when the location of the line is here, 10 are classified properly. Therefore, now the accuracy can be 10 by 16, that is 62.5%, when the location of the line is here. But we know that the problem is linearly solvable. So we are not satisfied here. So we have to improve the accuracy. That is machine learning. So how we can improve? Already we know if we change the values of C and W1, then the location of the line is going to be changed. So now how we can change the values of C and W1? That is the big question. For that, we have different kind of learning algorithms, right? So now we are coming to the introduction of the learning algorithms. So to change the values of C and W1, we have number of learning algorithms, like say gradient descent learning algorithm, stochastic learning algorithm, different kind of learning algorithms are there. Based on that, the values of C and W1 can be changed. Now say C and W1 have been changed. With this change values, the location of the line is here now. So once the location of the line is here, then this side can be considered as positive. So out of 9 positive samples, how many are positive now? 1, 2, 3, 4, 5, 6. And all of the negative samples, we have how many negative? 3 plus 7 plus 3, 10 negative samples are there. Out of these 10 negative samples, 7 are really negative. So how many samples are predicted exactly, means accurately? 13, because these 6 positive samples and these 7 negative samples. So out of 16 samples now, 13 samples are predicted as positive. So now the accuracy becomes how much? 13 by 16, so 81.25, right? Or still, the learning is not stopped. Why? Because the termination criteria is 100% accuracy. Why that is? Because already we know it's a linearly solvable problem. So for linearly solvable problem, we'll get 100% accuracy. Then again, the learning algorithm will change the values of this C and W1 based on the error rate. So now C and W1 is changed. So now, after changing this one, say the location of the line is here. Once the location of the line is here, now the problem is solved. Now, one side of the line can be considered as positive and another side can be considered as negative. So the problem is now solved. Now the question comes, you see that this is computer science and engineering, that everything has to be codified and the computer will do. So we are telling one side, another side, that is not sufficient. It has to be proved mathematically. And this mathematics can be codified actually, right? Only then the computer can work, otherwise computer cannot work. So now say that if the location is here, it is solved. If the location is here also, this is solved. If the location is in this way, also this is solved. Means we can have a number of lines here which can solve the problem. Now we consider one of the possible solutions when the value of C equals to minus 165 and W1 equals to 1. Okay. So by learning, we can consider one of the possible solutions when the value of C equals to minus 165 and W1 equals to 1. So now this is looking that how we can, this is the solution we got, and then how we can mathematically establish that you can say the truthness of this one side and another side of the line. So it can be very easily. So we're looking here. So taking the first sample. So for the first sample again, the sample can be represented by y equals to C plus W1 x1. So one of the possible solution is C equals to minus 165. So the value of C is how much? Minus 165 plus the value of W1 how much? That is 1. So 1. We have chosen which sample? First sample. For the first sample, what is the value of x1? That is 200. So simply here 200 is given. Now we have this expression for the first sample. You solve it and find out how much is the value. So the value becomes 35 here, right? For the first sample, the output value becomes 35. And keep in mind, the class of the first sample is what? Yes class. Now we can choose the second sample. Again, the equation is y equals to C plus W1 x1. So for C, how much is the value? Minus 165 plus W1 is 1. And x1 is different in sample 2. So sample 2, what is the value of x1? That is 250. So 250 is kept here. So if we solve this one, and finally it stands at 85. So for the second sample, the output value is 85 and the class level is yes. So coming to third one now, okay? Third one, same thing. So these are the values. And how much is the value of x1? 130. So if we keep here 130, and if we solve this one, and if we simplify this expression, finally it becomes minus 35. So for the third sample, the value of y becomes minus 35. And this is a negative sample. It can be noted. And now the fourth sample, if we keep all those values, then the expression becomes like this. And if this expression is now simplified, and we'll get a value that is minus 15. And this fourth sample is also negative. Similarly, we can take the fifth sample. And if we keep the values of all the values of the fifth sample, so for fifth sample, what is the value of x1? That is 135. So minus 165 plus 1 into 135. So this is the expression. Now, if this expression is simplified, it stands at minus 30. Okay. So again, one thing can be noted that the class level of 5 is how much? What? That is negative. And for this, what value we got? The value we got minus 30 here. Now we can take the sixth sample. For the sixth sample, the value of x1 is how much? 125. So we can keep all those values here. And if we simplify this one, then we get minus 40. For sixth sample, the class level is negative, and we got here minus 40. Similarly, we can solve 7. 8th, 9th, like that, all of the samples. And finally, here we have 16th sample. For the 16th sample, the value of x1 is 170, right? So 170 is kept here, and the values of C and W1 we have kept here. And now if you simplify this expression, it becomes 5. And the class level of 16th pattern is what? Y. Okay, so now see carefully that for all of the positive patterns, you can see here, the first one, second one, they are the positive. What is the value? We got here positive values, right? And third one is negative. For that, what value we got? Minus 35 means negative value. Now fourth one is what? Again negative. For this, again we got a negative value. And fifth one is what? Negative. We got negative value. Sixth one is negative sample. We got negative value. And the 16th one, that is a positive sample. And for this, we got a positive value. So now what we can do? We can make a threshold value. Threshold can be like this. If output value of the sample with this parameter values, because we learned these parameter values. Learning means learning of the parameter values. Here the learning means learning of the values of C and W1. We learned the values of C. How much that is? Minus 165. And W1 how much? 1, right? With these learned values, we have seen that. So if we simplify the patterns in these discriminant functions, then for the samples for which the output becomes greater than equals to 0, these are the positive. These are the one side. Whenever the output becomes greater than equals to 0, then we can say that is one side of the line. And if the value is less than 0, means the negative, this is another side of the line. So here we have seen mathematically how it is done. Because in computer science, you must have a mathematical derivation and steps. And those steps are going to be programmed, right? And then only the problem is solved. So this is one way how a problem can be solved using some machine learning. So one thing can be pointed out here. In this case, we have only one independent parameter, that is x1. So now we can have a more than one parameter, like say x1 and x2. And if it's a classification problem, then one of the way to solve this one can be like this, right? For this also, we can derive, or we can make one discriminant function, right? So in this case, the discriminant functions can be represented as x1. With x1, we can have a coefficient w1. x2 is another independent parameters. We can have a coefficient that is w2. With that, we can have a bias here to get it from a overfitting problem. So now this is the discriminant functions for a problem where we have two input values, like say x1 and x2, and one class label. Like this, we can have an n number of input attributes, and thereafter we can have a class label. So if we have an n number of attributes, then this discriminant functions has to be extended up to n number of, means xn, and similarly wn actually, and plus c. Okay, so whenever we have more than one dimensions, whenever we have more than one input parameters, then this line is not called decision boundary. In this case, this line is called decision boundary. So whenever we have the dimensions more than one, then this is called hyperplane. So now the same concept can be extended up to n number of attributes. And here we have solved a problem with only one attribute. So keep in mind, machine learning doesn't mean that always this kind of problem would be there. It's called gradient-based machine learning algorithm. So there are different kind of machine learning algorithm. There can be distance-based machine learning algorithm. There can be probabilistic machine learning algorithm. There can be rule-based machine learning algorithm. So long before here, so we have seen here the rules are created, right? So this is called rule-based machine learning algorithm. In this case, rules are being created. There is no concept of gradient descent, right? So like say decision tree, random forest, extra trees, these are the example of tree-based machine learning algorithm. So here just one way of representation we have learned. It doesn't mean that we learned all about machine learning, okay? So we have seen that how a problem using some machine learning can be solved, okay? So you can solve this problem using say statistical method, like the ordinary least square method. But in that case, you cannot change dynamically the value of C and W1. So you can find directly C and W1 by calculating mean, summation, all kind of things using statistics. But here, the statistics is used in a different way to solve the problem dynamically with the help of historical data so that the accuracy can be improved. That is machine learning actually. So coming next now here, so the definition which is mostly accepted by the research community of machine learning, that is given by Tom Mitchell, and here we have the definition. So this definition I'm not going to talk about. So if you write only Tom Mitchell's definition of machine learning, you'll get this definition from internet. Then coming next here, why machine learning? People, those who are doing research and solving problem, even those who are a postgraduate student and those who are doing a PhD, they jump into machine learning blindly without knowing for what situation this machine learning should be used. Therefore, just I have added this slide, right? So all of the problems should not be attempted using machine learning. Then why machine learning? For what kind of problems we need to use machine learning to solve? See here, this slide, we'll talk about all those things. We'll clarify our misconception about in each and every problem the machine learning can be used. See here, for some problem, if already we have established algorithm, then the machine learning should not be used. For an example, sorting numbers. For sorting numbers, already we have established algorithm. Therefore, sorting numbers, we should not use machine learning, right? Now we can have some situations where we don't have exactly established algorithms. We don't have established algorithm for solving such kind of problem, right? But for that problem, we have a huge amount of data. So in that case, machine learning should be used. One example is to tell spam emails from legitimate emails, right? So to detect one spam emails, we don't have an exact algorithm for that, right? So we have the algorithm, but the model parameters can be different for different people. For you, one mail can be treated as a spam. For me, that is not, based on the historical data actually, right? Even if the same algorithm, but the parameter values, learned parameter values can be different from different data sets, okay? And then one more, the problem where no human expert exists. For an example, if you're asked, can you tell me whether there would be rainfall tomorrow? You can guess only, right? You cannot tell exactly whether there will be rainfall or not. But you try to understand if we have the historical data, then if we analyze the data, then data will say us whether there would be rainfall tomorrow or not. Based on the patterns, the pattern can repeat after 7 days, can be repeated after 1 month, or there can be some kind of interesting facts which can be extracted by machine learning. And by that, we can say whether there would be rainfall tomorrow or not. Okay, one situation more. The problems where human experts exist, but they are not able to explain their expertise, like say speech recognition. Now say you are in a room, right? And outside of the room, you have 5 friends and they're A, B, C, D, and E. And somebody says something and you can recognize, oh, see, E is saying something. E is saying something. Yeah, you can identify. But now, if I ask you, how did you conclude? Can you tell me what is the reason that you can say this voice is E's voice? You cannot explain. You have the expertise, but you cannot explain. So now to explain this one, if you want to explain, then so voice recognition has to be applied there, or the speech recognitions. It analyzes all of the signals, then it fixes some kind of frequencies and pitches for each of the persons differently. Like for A, it can have a different pitches, a different kind of frequencies. For B, it can have different. For C, it can have different, like that. Means different rules can be for the different persons. Right now onwards, even if you are not there, intelligent algorithm is there. If voice comes and it can say that whether the person is A, B, C, D, or E, but you cannot explain. You have the expertise, but you are not able to explain the reason behind that. So if we have such kind of situation, in those situations, the machine learning can be used. Okay. Now we have a more situation here. The problems where the environment changes frequently, right? So as changes frequently, it means what? The nature of the event is chaotic. Abrupt changes is there. So if we want to use the simple mathematics, then this chaotic behavior and abrupt changes cannot be captured. Now to capture this chaotic behavior and abrupt changes, we need to have some kind of fancy mathematics, right? And these fancy mathematics is being provided by machine learning. One thing just I would like to add here, machine learning is not exception than mathematics and statistics. But in machine learning, the algorithms are designed in such a way that for each and everything, we don't need to do programming. That if we do something, then the whole thing can be done automatically, right? Therefore, if you ask me why the machine learning, even if the problem can be solved by statistics and the mathematics, then I'll say that machine learning is used to make quicker and reliable decisions. Because many times if you use the simple mathematics, your accuracy level cannot be better, cannot be up to the mark. But if you use a machine learning, the accuracy can be up to the mark and the decision can be taken very, very quickly actually. So the final conclusions, machine learning is used to make quicker and reliable decision. So for all this reason, actually machine learning is used. Now we're coming next year. So if we talk about the machine learning algorithms, I don't know, we have a very less time, but I'm trying to read in 5 to 10 minutes to wrap up actually.
Yes, sir, you
Machine
can take
learning
your time.
algorithms.
You can take your time, sir. Yeah.
Thank you very much. So the machine learning algorithms can be categorized in three categories. One is called supervised, unsupervised, and reinforcement. And for supervised learning tasks which are done, these are classification and regression. And for the unsupervised learning, the tasks which are done, these are and association rule mining. For learning, we do sequential, right? And now this sequential decision making can be done using classification, clustering, and many more tasks actually. So which comes under reinforcement learning, route navigation, traffic control, means whenever we have some dynamic situation, those problems become reinforcement learning. So simply here, this kind of problem means we have a set of input, get output. Clear? So problem are called supervised problem. When this target is a discrete value, then we can say that then we say this is a classification problem. These are the input values, roll number, based on that we're finding here the weight, right? But it's a continuous value. We have a target, but continuous value. When the target is a continuous value, this kind of task is called regression task. Okay? So this kind of task can be done using set of machine learning algorithms. So which are the popular and the machine learning algorithm? So here just I have these kind of algorithm, which are in black. These are especially used for the classification tasks. And red, these are especially used for regression tasks. But keep in mind, the algorithms which are used for the classification, the variants of these algorithms also can be used for regression tasks actually, right? So here, that I'm not naming, so you see the slide. You can take the snap of the slide. Don't request for the slide, you can take a snap, right? If you are interested. So these are some of the name of the machine learning. You can say the algorithms. These are especially for the classification and especially for the regression task. And then the supervised learning means this kind of scenario we must have. Then coming next here, if we have a problem, and in this problem, say this is one sample X1, and this sample is described by three attributes. Say this is an assumption only, right? A1, A2, and A3. These are the items. But against these items, we don't have any class level. Only the samples are there, but the no target level is there. So whenever we have this kind of data, and if we do some kind of learning here, that kind of learning is called unsupervised learning. Now the question comes that no target pattern is there, then what kind of learning we can do here? Yeah, the learning, what we can do, these are called, one is called clustering, another one is called association rule mining. All of the things cannot be covered up. Two things, these are which are interesting. These are I'm telling. Now say that we have a transactional data of a business supermarket here. And X1 is a sample which describes one transaction. X2 define another transaction. X3 define another transaction. Clear? And by these transactions, we can have these items, whether the items are bought or not, for an example, right? Now say out of this, the transactional records, we found that A1 is the most frequent item. It means that A1 is most frequently purchased item. Okay. And by this association rule mining algorithm, we can find out with this A1, which item is most frequent. The case can be with A1, the most frequent item is A2. How much is the frequency? What is the percentage of frequency? This also can be found. Now say the percentage of the frequency is 80%. It means that whenever item 1 is purchased, in 80% cases, A2 item is also purchased. So this kind of relationship we can find. So if it is, so whenever we'll place order for some items. So whenever we'll place an order of item A1 for say 100 items, then at the same time we have to place the order for A2, how many items? At least 80 items, because from the transactional data it is observed that in 80% cases, whenever A1 is purchased, A2 is also purchased. It means that if we place an order of 100 items of A1, then we have to give an order of 80 items of A2 also, so that there won't be any disparity between A1 and A2. Number one. Number two, if it is so frequent, A1 and A2, so when we arrange the product in the supermarket, then wherever we keep A1 in the nearby places. We have to keep A2. Why? Because whenever somebody buys A1, the person is also interested for A2. So this kind of analysis can be done in, say, business and the business organizations by, say, data analyst actually. Okay. So in that way, actually, organizations are profitable and many things are there, right? Many kind of problem. I'll show you some of the problem coming, right? So thereafter, we have another category of classification that is called reinforcement learning, but we're not going to talk about, we cannot complete, right? So these things are there, these things are there. Now, what are the prominent or you can say trending applications of machine learning? Here we have some of the trending application of machine learning. One of them is what? Image recognitions, means face record detection can be done, speech recognitions, then what? Traffic predictions, product recommendations, self-driving car, email spam and malware filtering, online fraud detection, stock market trading, weather predictions, medical diagnosis, automatic language translation. But in detail, I have presented 2 more applications. So these are the trending applications. Try to understand. Those who are trying to do research in machine learning, they can catch any of the problem. They can start their research. I can help, no problem, right? So Arindam sir is there. I know him, right? If you are interested via him, we can do the research. There is no problem. Students comes, especially the faculty members. And then we're coming here. So I would like to show you some of the avenue, how we do actually you can say the findings and solving the problem using machine learning. So especially nowadays, there is a boom of smart farming. The smart farming can be done using some machine learning. Under smart farming, we can have a number of problems, right? Some of the problems I have pointed out here. So these problems are what? Soil monitoring. We'll see in detail this one. Then crop monitoring. Then livestock monitoring. Then which one? Automated irrigation. Then crop yield prediction, pest and disease management, supply chain optimizations. And in each of the cases, these can be the target parameters, especially for the soil monitoring, seeding rate, one of the possible target parameter. There can be many, but one of them is like this, seeding rate. Similarly, for crop monitoring, one of the target parameter can be crop health status. Similarly, livestock monitoring, so these can be the targets, either health status or status or what? Disease type like that, right? And for crop yield predictions, we have a crop yield. And now pest and disease management, the target can be treatment or recommendation, whether treatment is required or not in the agricultural field. Okay. In supply chain management, the target can be the demand forecast. What would be the demand, right? Next year, you are cultivating something, but you could understand there is less demand, then you should not cultivate that amount, right? And if you feel that the demand would be more, then you cultivate more so that you would be profitable actually. In that way, actually, data science is used to gain, or somehow using data science, the organizations are becoming actually profitable. So we're looking one of the example right here, how this soil monitoring can be done. So in case of supervised learning, because these are the fundamental learn, actually many parts are there. Those parts are not included due to paucity of time, but at least I have shown you we can have this kind of problem where we have this kind of inputs and this is the output, right? This is called supervised learning. It means what? We'll have a number of inputs. Based on these inputs, the output can be determined. Okay, so now looking the problem, soil monitoring. But soil monitoring, what kind of things we do in smart farming? See here. So in case of soil monitoring, we can have a different kind of soil parameters, right? So the soil parameters are like, say, soil pH, their organic matter content, soil texture, many more like that. Up to how many? It can be 19 parameters. These are the parameters related to soil here, and some others also. Based on that, it can be decided the seeding rate. So based on the expertise of the domain expert, already we have this kind of database. Try to understand in this database how many input. See here in this database how many input parameters we have? 3. Based on that, we are finding the class label. But in this case, how many input parameters? We have a total 19 parameters. But in this way, this cannot be represented. Therefore, just I have presented in this way, right? 19 parameters we have, and based on these 19 parameters, we can predict the output, that is the seeding rate. Just I have taken this data from the Kaggle actually. One of the data sets, you can make the data differently. If you have a very specialist agriculturalist, if you have, then you can make the database differently. That is up to you. This is one of the standard database I have downloaded from Kaggle actually, right? So in this database, there are 19 input attributes. Based on that, it is predicted seeding rate, means the target parameter is the seeding rate. So now in this kind of database, there are 1,000 and 1,000 patterns. As we have 1,000 and 1,000 parameters, already we can train one machine learning algorithm. After training the algorithms, right, based on the situation now, so in Assam or it can be Meghalaya, based on the situation now, we can give the weather, the soil parameters of that region. Once we give the soil parameters and others of that region, that it can say that for that soil actually, what should be the seeding rate. So it's a kind of smart farming. Means we are finding what should be the seeding rate based on the historical data and using machine learning. So it comes under smart farming. Okay, so similarly, we can have another kind of problem here, right? In this case, what happens actually, based on these parameters, we have some vegetation index, we have some weather parameters. Based on that, we are predicting crop health status. This status, because in many places, big countries, as actually, it is not possible physically to check the say crops and determine whether there is some disease or not, or what is the health conditions. In those countries, for the big, say agricultural land, what do we need to do? We need to use a drone and satellites. Using this drone and satellites, we can take pictures and images. By analyzing the image, we can say whether the health of the crop is good or bad. If it is found that the health of the crop is not good, then some kind of medication, some kind of treatment can be recommended. Okay, for that case, for one of the data sets I have downloaded. So in this database, actually, these kind of input parameters are there. So vegetation index. Then we have here what? We have here some weather parameters. And based on that, the crop health status is predicted, whether the status is good or bad. Okay, so once we have these inputs, then it can automatically detect that whether the health is good or bad. So if the health is bad, then say we can intervene, or the agriculturists can intervene so timely to monitor the health of the crop. So in that way, you can say the agriculture sector can be benefited using say smart farming or using the concept of smart farming. So this kind of tasks actually we do in smart farming. We can have one more, I think. This is crop yield prediction based on the crop type, soil type, nitrogen level, phosphorus level, means based on vegetation type, based on soil parameter, based on weather parameter, and something more. We can predict that how much yield is going to be grown up, so that beforehand you can estimate the crop yield, means how much crop is going to be grown up. So accordingly, you can plan. That is called crop yield predictions. Based on these parameters, we can estimate how much crop is going to be grown up from this cultivation field. So this is another kind of, you can say, application in a smart farming, application of AI and machine learning. Similarly, we can have a different sector. So in finance sector also we can have a different problems actually. In finance sector, the prominent problems which are solved using some machine learning, these are fraud detection, expense categorization, audit automations, forecasting and building, budgeting, loan default predictions, churn prediction, personalized banking and automations, customer recommendations, credit risk management, many more, and finally here ATM cash forecasting. So many problems are here. So looking one of the problem, what is this actually? Now, in this problem, what we are trying to predict? Loan default predictions. So whenever somebody applies for a loan, then we are trying to find out that whether the applicant is going to be a default or not. What is the possibility that it will be a defaulter loan? If it is a defaulter loan, then loan won't be granted. So we can find out the possibility here. So if the possibility to become loan defaulter is very less, then the loan should be granted. Now, one of the data set I have downloaded in this database to find the loan default status, they have used these parameters. What are these parameters? Borrower demographic attributes. Under demographic attributes, we have these things: customer ID, age, gender, marital status, then education level, employment status, many more are there. And then we have another kind of attributes, that these are financial attributes: annual income, monthly income, debt to income, credit score, many more. Then we have another parameter that is called loan attributes. Under loan attributes, these are the parameter. And similarly, we have a credit behavior attributes. Under this, these are the parameters. By analyzing these parameters, it is decided the possibility of the loan default. How that should be done? Because beforehand we'll have a database. So in this database, already one machine learning algorithm is trained. The trained machine learning algorithm is available. Now, if somebody applies, then he has to fill up these parameters. So those parameters can be given as input, then the loan default status would be predicted. If the probability is very less, it means that to become a defaulter, the probability is very less, means the loan can be granted. That is up to you. But the analysis is done based on artificial intelligence and machine learning. Okay, so it's a smart decision actually, right? And at the same time, we can have another kind of problem, so ATM cash forecasting, right? So in this problem, what would be the demand of the cash of an ATM machine, right? So tomorrow, how much cash may be demanded? Accordingly, the cash can be deposited to the ATM machine. How it can be analyzed? For that, again, I have taken one database, right? So in that database, the parameters of the attributes which were taken or which are taken for this analysis, these are what? ATM and location attributes. Okay, this is one attribute. Under that, we have 7 attributes. Historical transactional attributes. Under this attribute, we have a total 6 attributes. Then cash refill history attributes. Under that, we have 5 attributes. Okay, temporal and calendar attributes. Under that, we have 6 again. Then derived attribute. Under that, we have 5. And external attributes like weather conditions, event tag, local business. Each and everything has been taken care here. So number of inputs in this problem becomes 32. And based on that, it decides how much money can be demanded or would be demanded next day. It can be predicted. Once we can find out the estimation, accordingly, that amount of money can be deposited or can be stored in the ATM machine, right? So there won't be any kind of shortage in the withdrawal of cashes. Okay, so this is also a kind of a smart decisions actually, right? So these are the problems which comes under machine learning and AI in our day-to-day life. Now the question comes that if we want to design one AI model or the machine learning model for AI tasks, then how we can design? For that, I especially in my research lab, we follow this kind of sequence actually. And there can be something different, a bit different in some other model, other research lab, but in most of the cases, the flow should be like this actually, right? We must have a data sets. We must have a problem definition, what we are trying to solve, and how the data set can be built. The whole part, actually, we're telling this is using machine learning, but whole part is data science actually, means AI model using data science. Machine learning is a part of data science. So whenever we talk about some problem is being solved, if we see all of the steps, all of the phases comes under data science. A part is called only machine learning. Okay, so more accurately, it should be AI model using data science, but I have written using machine learning because the topic is like this. So we must have a data sets, and then we have to pre-process the data. That is called data analytics, in which comes under data science. Okay, so under this data preparations or the data pre-processing, we have to do this kind of job. What are these actually? Removal of corrupted data, handling missing values, data visualization and data exploration, outlier detections, treatment of class imbalance problem, feature analysis, and thereafter data normalization. These normalized data can be given for modeling and evaluation. For modeling and evaluation, the first step is a model selection, because for classification tasks, we have a number of classification algorithm. But out of number of classification algorithm, which one should be used for this problem? And that phase is called model selection. For that, we have to study a lot actually. We have to study statistics a bit, a lot. So here data science is required. And then model training. Once the model is selected, then the model has to be trained with this model. And then model has to be evaluated. Then the model can be deployed. This deployment of the model is not included here. So how the model can be designed, that one is given. After design, it can be deployed based on the applications. This part is not included here. Okay, so these are the steps just I have shown you, but those things are not discussed here because each of the step we have to discuss for that big session and big say lectures, because during data science, in the course of data science and machine learning, we study about these phases actually. Number of algorithms are there, number of things are there, number of analysis is there. Those things are done one by one. Okay, but this is the flow. If you want to design some AI model using data science or machine learning, then you should follow this flow actually. Data science, data sets means that we have to define the problem. Based on the definition of the problem, data set has to be created. And once data set is created, then data preparation is required. Why? Because machine learning learns from the data, okay? From the historical data. Now, if the quality of the historical data is not good, then the learning won't be good. So you want to have a better learning so that the quality of the data would be better. So to make the better quality of the data, we need to have a data preprocessing, or that is called data preparations. Under data preparations, these are the prominent job actually, right? So if these things will be there, then the quality of the data will be good. So whenever we have this kind of thing, those things have to be treated. And for treating those things, we have a different kind of techniques actually. Right? These are the content of say machine learning and data science subject and data analytics subject. Okay, thank you very much. Thank you. If you have any questions, then we can discuss.
Thank you so much, sir, for the presentation. Sir Yuvraj.
Yes, thank you so much, sir. For the question and answer round, we have some questions from YouTube, but I would like to first give option to the ones who have joined in Zoom. So anyone who wishes to ask any question, please unmute yourself and you can ask your question, or you can write your question in the chat box. Anyone?
Anyone who is there in the Zoom, please ask. But Sir Yuvraj has asked one question in the chat box. Sir
yes,
Saroj, can you?
I am interested in image analysis.
And
thereafter, the question is not there actually. Then what?
Yes, sir. The follow-up question is this: how do you prepare images for machine learning? How do you label the important parts that you are interested in? How do we do that for image analysis?
For image analysis nowadays, there is a trend that is called deep learning, right? Deep learning, you have to know the deep learning. So because if you do the image processing and image analysis using say conventional machine learning algorithm, then you have to do a lot of things, like say you have to extract the features. Some of the times the image may not be so clear. So you cannot get all of the features of the images. So it may mislead. Therefore, nowadays there is a trend of deep learning, especially for the image and videos. There is a deep learning technique that is called CNN architecture, convolutional neural network. So you have to know convolutional neural network, then you can analyze, you can predict something very easily.
Thank you, sir. Yeah, anyone else from Zoom, if you are interested in any questions, please feel free to ask.
Before that also, if anyone is there, please ask. I'm asking, I got one question in my WhatsApp. Dr. Navnita Kumari from Bihar, she also completed her PhD from NIT Silchar only in physics. I don't know whether Sir Saroj remember or not.
I can remember.
Okay. She has asked, is the data or results provided by ML reliable because it gives only results by reading the pattern?
Yeah, exactly. It is reliable because nowadays there is a trend, there is a number of applications of machine learning. So it is reliable, right? So you see that if the problem is highly nonlinear, then it's true that 100% accuracy you cannot get, but you can get less accuracy. But it is reliable because nowadays, whichever things are done in the industry, all are based on machine learning actually, right? So we can have an AI system. If you want to make the AI system more smarter and more autonomous, then machine learning should be used. So driverless car, this is the application of machine learning. Because in the driverless car, actually, the deep learning architecture is used, especially CNN architecture is used. It works. It is reliable. Yeah, it's true that machine learning means we are trying to find out the approximation. But now the machine learning has reached in some level so that this approximation works in reality. Actually, it works.
Sir, there are two questions in the
Somebody has written, can you please explain generative AI and agent AI and how we can build such process using machine learning and data science? Yeah, that's a generative AI as a part of machine learning, right? Especially if you know, again, generative artificial neural network. That is called generative AI. Actually means you are going to generate something. For an example, if you want to generate some duplicate picture, so that is generative AI, right? So for an example, from Sketch 2, many is the use of generative AI. Say that you have one sketch, but you want to make one say face image. From sketch to face, it can be generated by GAN neural network. It's generative adversarial neural network. There is huge, right? It can be. Generative means you are generating something, right? So based on the historical data, we can generate. So from sketch to image, there is a huge trend of this kind of job. From sketch to image. Many times actually, wherever there is some criminal case, so artists can make sketches. From this sketch, they can, and the AI means generative AI can generate which one? The images. Generative AI means what? Generative AI, already you have Chat GPT. This is the application of generative AI. And ChatGPT based on what? It's based on transformer model actually. ChatGPT is transformer model. This is the application of machine learning.
Sir, there is, I think, one more question. Can we use algorithm in Excel sheet? Pretty sure what? Yeah.
Can we
use algorithm in Excel sheet? I think probably what they mean is like, can we use any AI in Excel sheet, like for data sets?
Audible. You are not completely audible. You can type here.
Yes, sir. No, I mean, like there is one question in the chat which says, can we use algorithm in Excel sheet? I think probably what the questioner wants is, can we use AI for data analysis?
Yeah, for data analysis. See, data analysis, yeah, it can be used. Yeah, for data analysis, machine learning algorithm can be used. This is also AI. It can be used for data analysis. Data analysis is done by data science, and data science is the part of AI. Try to understand whichever we are doing, data science, machine learning, data analysis, all are the endeavor of each and every task is to make one AI system actually, right? So this machine learning, data analytics, data science, all are the part of artificial intelligence.
Okay, sir. Then I'll take a few questions from YouTube. The first question is by Nilo Yedi. How effective and reliable is AI in meaningful abstract writing?
Meaningful?
Abstract writing. I think probably abstract of a paper or something like that. Abstract
Meaningful?
writing. Abstract.
Yeah, this is possible. This is possible nowadays. From the ChatGPT, many people they do. It is possible. It is possible. But the intentions, aim can be something different. Objective can be something different. Your conclusion can be something different than the conclusions which is drawn by ML or say ChatGPT. Maybe something different. But it is possible.
The next question is by Shriti Kona Vaidya.
Before that, sir, one more question is there by Kishan Coach. What are the side effects of AI?
Side effects of AI like that. So somehow I should not say this one, right? So the tasks are going to be very efficient, so that for some tasks, even if earlier say human resources were being used, now the human resource, no amount of human resources was a task. Those tasks can be done very easily by AI. But AI also creates number of jobs or job opportunities if you are skilled enough, right? So side effect means it tries to kill, it tries to reduce the number of jobs, but it also creates a number of jobs at the same time. Actually, I could understand. He tried to mean this one, I think.
Yes, I also believe that. Yes, sir, Yuvraj.
Yes, sir. The next question is by Shriti Kona Vaidya. How do you ensure fairness and transparency in AI decision making?
Repeat, please. Transparency and
fairness and transparency in AI decision making. AI decision making.
Again, just no, read the
AI
questions. What's
Okay, I'll read out. How do you ensure fairness and transparency in AI decision making?
Yeah, in AI decision making, there is transparency also, because you have to know a number of techniques. Because already you have seen that using say DT decision tree, we can make a transparent decisions. Means how the decisions are being taken, the rules are given. We have seen that for this heart disease predictions, the rules are being made by AI algorithm. It's one of the machine learning algorithm. So it's true that for all of the machine learning algorithms, the transparency is not possible. But for some algorithms, but machine learning is having some algorithms where we have a transparency, like say decision tree, random forest, and also you can say extra trees. And also for neural network, we have different kind of algorithms by that neural network can be made transparent. And people are working on this also. So many researchers are working how the black box AI tools can be made white box. So white box means the transparency. Means if we take one decision, just in many algorithms, just we know only the answer. This is yes, no. But how the decisions are being taken, what is the rule behind that? What is the logic behind that? This is not given. But we have some of the machine learning algorithms where these things are given, and that is called transparency actually. So for some machine learning algorithms where transparency is not there, the researchers are working how those tools can be made transparent. Like say support vector machine, an artificial neural network. It is a you can say trending you can say trending area in the topic of research. How artificial neural network can be made say white box, means a transparent. Okay.
Okay.
I
think two more from YouTube. Sir Yuvraj.
Yes, sir.
Yeah.
I think we should stop from YouTube. We cannot finish up. Many questions.
Yes. No, those we have given beforehand. Two more questions are there. Then we will answer the one who has given in the Zoom. So actually, it is more or less the same thing only. Susmi Marak is asking, does ML explicitly account for any possible error percentage, and to what extent can we be confident that predictions are absolutely correct given that the inherent possibility of error?
It depends on the problem. See, listen, because we have presented only one small presentation so that it is not possible to show all of the things. See that if the problem is linearly solvable, then for those kind of problem we can get 100% accuracy, means the error rate can be 0. But if the problem is highly nonlinear, right, in those cases, the accuracy cannot be 100%. The accuracy can be very low. In those cases, the error can be very high, right? But still, if you want to say that the problem for which what kind of or what percentage of say error should be there, so that it can be say working problem or the working solution, it depends on the applications. So if the accuracy is around say 95% or 96%, you can see that this one can be adopted in the application domain. But one thing pointed out, that how much sensitive your application domain. For an example, you are doing something in say medical diagnosis. In that case, if there is 1% means 1% misaccuracy, or that if there is a little bit error, but still it cannot be accepted, especially in case of medical diagnosis. So it depends on the application area. Try to understand.
Okay, sir. Last question from YouTube, I think. Is it possible to develop AGI and ASI?
AGI full form is what? What he tried to say.
So that's a thing. AGI and ASI.
No, it's not clear to me actually. The full forms are not given.
Artificial general intelligence and artificial super intelligence, if I'm not mistaken.
No, this is not clear to me actually. So let it be. So artificial general intelligence. So artificial general intelligence, and then ASI is what?
Super intelligence. Artificial super intelligence.
So I could not understand this question actually. Let
Okay,
it be
sir.
then.
Okay,
right?
sir.
I could not because he wanted to ask something else probably. But if you sit together only, then this is possible. So you can find out the answer.
Okay, I think from YouTube we'll not take up any more questions. So 2-3 questions are there from our colleagues who have joined here. Sanbor Khargaonkar has asked, how can we differentiate between a student's original writing and writing generated by AI?
Yeah, there's the handwritten recognitions has to be applied there, and it's really very difficult, right? So, so for machine learning tools, that I don't know exactly right how far it can be. And that if it is, then we have to train and we have to see that, right? So we have to take some of the samples from the students and some of the samples from ChatGPT. Then we have to train and then we have to see that whether machine learning can distinguish or not. Otherwise, it's very difficult to say, right? I didn't do such kind of experimentation. But it's true that if there is some deviation, it can be. And there must be some kind of deviation. There would be some kind of deviation.
Sir Yuvraj?
Ah,
Yes.
yes, sir.
Yeah.
Yeah, that will be okay for today because we have already exceeded the time. So with this, I would like to hand over to Father Principal for the concluding part.
No. I think, sir, Father wants to say something. Father, you can just come in, and then after that, we will give the vote of thanks from Sir Gaurav.
Okay, since my name has been mentioned, on behalf of everyone, I would like to be very grateful to Dr. Saroj Kumar Biswas. Initially, when it was little bit scientific, etc., I was finding it slightly difficult to understand, but later on, every bit of it I enjoyed. And I would like to be very grateful to him for his time.
Thank you very much, sir.
And for his availability to animate us today, and for all the organizers for reading out to him the questions that participants have asked. So once again, I would like to be very grateful to you, and over to Sir Gaurav for the vote of thanks.
Am I audible?
Yes, please go ahead.
Good evening, everyone. As we come to the close of the insightful and engaging webinar, it is my privilege and honor to deliver the vote of thanks on behalf of the Department of Physics and IQAC Don Bosco College, Tura. First and foremost, I would like to express our heartfelt gratitude to our speaker, Sir Dr. Saroj Kumar Biswas, Associate Professor, Department of Computer Science and Engineering, NIT Silchar. Sir, your presentation has been immensely informative and thought-provoking. You have truly helped us understand the real-world application and impact of artificial intelligence and machine learning in smart decision-making. Thank you so much, sir. A sincere thanks to our respected principal, Father Januarius S. Sangma, SDV, for his continued encouragement and support, without which events like this would not be possible. I also like to thank Dr. Arindam Ghosh, Mr. Mahidar Rajbangshi, and Dr. Yuvraj Sharma from the Department of Physics for their leadership and involvement in organizing this webinar, as well as all the faculty members from our college who worked behind the scenes to make the webinar a success. To all the participants, thank you for joining us today, for your active engagement, and for making this session interactive and meaningful. A special thanks to our technical team, especially Sir John Satish, for ensuring the smooth conduct of the session across Zoom and YouTube platforms. Before we conclude, I would like to remind everyone that certificate will be issued only to those who submit the feedback form. The link will be shared in the chat box and will remain open until 8:30 p.m. today. With that, I officially bring this session to a close. Stay happy, stay curious, and keep learning. Thank you and have a great evening.
Thank you, Sir Gaurav.
Thank you very much, everybody.
Thank you, Gaurav. Again, yeah. So thank you, Sir Saroj. So hope to meet you soon, whether in online or offline form, but I hope we'll meet soon. Thank you so much. Yeah. And
thank you very much.
Yeah.
Thank you, sir. Thank you. We shall meet again
Thank
someday.
you so much, sir.
And I would like to this one apologize for those questions which we could not do it from the YouTube. There were many questions towards the end. I believe there were questions from Chiller Blocks, then Chesrang Agotok, then Somar Saha, then Ninja, then it was Ferindi Marak and Captain Mohit. All this we could not. So we apologize for that because the time was too much for that. Okay. So thank you. Sir Soroj, you can just exit. Yeah. Thank you.
Okay. Thank you very much. So one thing I would like to know, so how
Yes.
many candidates was there online maybe so on say YouTube around?
YouTube plus minus 80.
Oh, 80. Okay, thank you very much
Yeah,
for the
and
audience
here
as well.
it
How
was
many names were there actually?
yeah, here it was above 60. So
thank you.
approximately 150, 145,
Sure,
150.
thank you.
Thank you. Thank you.
Thank you.
Thank you,
once
sir.
again. Thank you very
Yeah.
much, everybody. Thank you.
I think, Sir John, you can stop the recording now. Sir John, have you stopped the recording? Yes, I think now we can just discuss a little bit. Yeah.
Thank you, Arindam.
Yeah, thank you, Father.
Very
I hope
nice.
it was okay.
I personally enjoyed, benefited quite a lot also. Yuvaraj, thank you so much.
Thank you,
Gaurav,
Father.
John Satish,
Thank you, Father.
he helped me so much. Mhm. And many others who participated.
Yes, thanks to all our colleagues, whether in